operations, what do we mean by operations again? It's a vocabulary term. What are operations? Okay, that's a verb. Yeah, it's the things that we do with our number sets, like what? Give me examples. Add, multiply, subtract, exponentiate, all that stuff, right? So let's just review some things. Again, this is just kind of beginning of the year review stuff. What about the top one? We're subtracting. How would I deal with fractions there? What would I have to do? Say it again. Okay, good. I need common denominators, don't I? Right. So I know you guys have done this many, many times, but what is a common denominator? Describe that. Okay, common means same. How am I going to, so if I want to find common denominators, you guys recognized immediately that the common denominator here is what number? 10, yeah. Okay, so 10, how do we arrive at the number 10? How come 10? Yes, sir. That's it. It's the least common multiple, right? It's the smallest number that they both divide into. Okay. Now this is a really simple example, but what happens when you get to maybe some bigger numbers? How could you come up with the least common multiple? There's a couple ways to do this. I don't want to spend too much time on this, but if I look at the multiples of 5, what would those be? 5, 10, 15, 20, etc. The multiples of 10 would be 10, 20, etc., right? Okay, so what if we had big, clumsy, awkward numbers we're dealing with? If we're going to use this strategy, then which list would I step through to find the least common denominator? 10 or 5? 10. You always start with the biggest denominator, and you're going to step through its list of multiples until you find the one that works for all denominators. It's more efficient, okay? So in this case, you were right. We just had to multiply this one by 2 over 2, right, to get a common denominator. And so we end up with 6 tenths minus 9 tenths. And once I've got a common denominator, remember, when I've got a common denominator, I can squish the fractions together and write them with a single denominator, right? And you guys, again, I know you guys know all this. I just want to say it once just in case you're a little rusty. So now we could take everything on top, which includes the operation connecting the fractions. So I've got 6 minus 9 over my common denominator of 10. So what's my answer? Good. Now, where does the negative go here? I mean, I wrote it out front. There's 2 okay places for it to go. Good. Could go in the numerator. I prefer to put it out front with a fraction. I think it's a little better because then you're thinking about a negative real number that just happens to be a fraction, right? Where should it not go? Denominator. That's awkward. Yeah. Okay, so how about the next one? What is the answer to that? Not 25? How come? You're right, it's negative 25. How come it's not 25? Okay, not in parentheses. Because we have to follow order of operations, don't we, right? Now, we haven't yet talked about that, but you guys all know order of operations. What comes first, exponentiation or multiplication? Good, the E comes before the M, doesn't it? So then that means we have to square the 5 before we multiply by the coefficient, negative 1. Okay, so that answer is negative 25. Now, if in fact I want to square the negative number negative 5, I've got to put it in parentheses then, right? And that gives me 25. Okay, give me thumbs so far. How we doing? This all coming right back to you. Any questions? Okay. How about something like that guy? What if I'm taking a fraction to a power? How do I deal with something like this? There's a couple different ways I could do this. Okay, how'd you get the negative? You're right. First of all, how do we know what the overall sign is going to be when I simplify this? Okay, good. It's an odd exponent. And if I take a negative number to an odd exponent, odd power, it's always going to be negative. A negative number to an even power is positive. Okay, so we know right away that we're getting a negative answer, then how do I deal with the fraction part? How do I deal with the 1/4 quantity cubed? What do you do? What's our property of exponents there that we would use? How'd you get, you guys told me 1/64, right? How'd you get that? What'd you do? You could just multiply successively, but we can be a little more efficient than that. Okay, there you go. I'm just going to cube both the top and the bottom. There's my point. Okay, and that's going to give us our negative 1/64. Okay, good. Okay, what about this one? Negative the quantity 25, square root of the quantity 25/44. Okay, first of all, is our answer real or non-real? It's real. Yeah, good. So the negative is out front of the square root, so it's fine. It just stays out front, right? How about the square root part? How do I deal with the square root of 25 over 144? Remember that? Say it again. There you go. Square root the top and the bottom separately. Okay, so then we're just going to end up with negative out front, and then square root of 25 is 5, square root of 144 is 12. Okay. Now, sometimes we can do, in this case, we couldn't, but let me give you just another quick example. What if I gave you something like this? Okay, this is not a great example in some ways, but you can see my point. I could just break this up into square roots of the top and the bottom, but is there something else I could do here that's going to make this a little bit easier? Yeah, you can always simplify the fraction before you split it, right? So this is one where I could simplify that. Both numbers are divisible by 6. And so then I would get 6/7, and then we'll go from there later. We're not quite up to that step yet, where we've got square roots stuck in the bottom. We'll get there soon. But the point is, simplify if you can. What about that one? Real or non-real? How come? You're right. Ah, there you go. You can't take an even root, square root's an even root of a negative number. So because of that, the answer is non-real. Okay. What about the bottom one? Fourth root of 16. Real or non-real? Real. It's positive. Yeah. How do I do? What's the fourth root of 16? 2. How come? You're right. Why is the fourth root of 16 2? That's correct. How come? Because 2 to the fourth is 16. Okay. Right. So exponentiation and taking roots, right? 2 to the fourth and fourth root of 16 are just opposite directions of the same process, right? They undo each other, called inverses. Okay. Give me thumbs. How we doing? Okay. So now let's review PEMDAS, order of operations, right? So we know that when we're simplifying, which is what we're doing now, we always start at the top and work our way down. Well, what's the P stand for? P stands for a lot more than just parentheses, right? P stands for anything that groups stuff together. Parentheses are grouping symbols, so any kind of grouping symbol or grouping operation counts as a P. So it could be parentheses, could be brackets, could be script brackets if we're doing algebra, we're not dealing with sets. But it could also be things like, fraction bars, right? If I have fraction bars, there are always implied parentheses around the numerator of a fraction and the denominator of a fraction. It could be things like functions. Like if I have a square root of a bunch of stuff, then everything inside the radical is all grouped together. So I'd have to start inside the radical and simplify stuff first, right? Does that make sense? We'll look at some examples. So after we deal with things that are grouped, and we'll talk more about that, then we move down to exponents, right? So we have to take care of evaluating any exponents. What's another operation that would get grouped in with exponents? Do you remember? Roots. Roots. For reasons that we'll talk about later. Roots get, well, actually, let's talk about it now. Why would roots go in with exponents? If I say the square root of x, that's the same thing as saying x to what power? Anybody know? Not 2. 1/2. Okay. How about the cube root of x? That's x to what fraction do you think that is? 1/3. There you go. So the moral of the story there is we can always write roots or radicals as fractional exponents. So they're just exponents, right? They get lumped in with exponents. And then M and D, multiply or divide. So does that mean multiplication always comes first? No. What's it mean? Left to right. They're on equal footing, right? They're equivalent. I just go from left to right. Whichever one of those I see first, I have to do. Same thing then with the bottom step in our ladder, which is addition and subtraction, left to right. Good, okay? Okay, so let's just try a couple examples. So 20 divided by 2 times 10. Okay, you guys talk about that amongst yourselves here real quick. Just check each other. What's the answer going to be? I'm hearing some different things. What's it going to be? What do you think? Be brave. 100, yeah. How did we get 100? We get 100 because what's the first thing I have to do? 20 divided by 2. Yeah, 20 divided by 2 is 10 times 10 gives us our 100, right? Okay. Okay, how about this guy? What's the first step? 1 minus 4. I've got to work inside the parentheses, inside out, right? So inside the parentheses, I've got 1 minus 4 is negative 3. Okay, so first thing we did was P, inside the grouping symbols. What's next? Exponent, good. So I've got a negative 3 squared. What's that equal to? 9. Okay, so I'm going to replace the negative 3 squared with a 9. What's next? Multiply. 2 times 9 is 18. And then finally, add. 1 plus 18 is 19. Okay, give me thumbs. How we doing? Is this ringing a bell? Is this all coming back to you? Okay. Okay, so how about this? What if we start with a big fraction like this? Okay. So what's that mean? Well, there's implied parentheses around the numerator and the denominator. So it's not there, but technically we can always think of grouping symbols around the top and the bottom. So I've got to work inside each set of grouping symbols and they're completely separated. So what's that mean about a strategy? Well, we can just separate the top and the bottom and work on each independently. Simplify the whole top, simplify the whole bottom, and then once I've got the top down to a single number and the denominator down to a single number, then I'll divide. Okay, but first I have to simplify the top and the bottom. So what can I do on top? What's first? Okay, there's even one step before exponents. Absolute value. Okay, so absolute value counts as a grouping symbol, doesn't it? That's grouping everything inside. Well, there's nothing to do inside. Negative 2 is all I have. But what is the absolute value of negative 2? 2. Okay. How about the bottom? What's the first step? Square root of 4. Okay, square root of 4. So the very first thing I'm going to get is that, right? What's next on top? Exponent. 2 cubed is 8. Okay, so the top is going to look like 8 plus 1. How about the bottom? What's left on the bottom? -9. I'm just adding up like terms. And then finally on the top, 8 plus 1 is 9. 9 over -9 is -1. Okay? Yikes. What about something like that? Lots going on. Yeah. Okay, good. So when I've got nested grouping symbols, so operations inside operations, we always have to start when we're dealing with the P part, the grouping symbols, we start in the inside and work our way out, right? Okay, so it looks like I've got these big grouping symbols on the top, the brackets. Inside that, there's a bunch of stuff going on. Okay, but look, I see parentheses inside the brackets. So we got to look inside the parentheses. Inside the parentheses, how many grouping symbols do you see? Show me with your fingers. Inside the parentheses. Okay, good. I'm seeing 2, aren't I? One of them is the absolute value. What's the other one? The square root. I've got stuff inside that function, so it's grouping the stuff inside. So what's my first step then on top? Yeah, inside the parentheses, I've got to deal with everything that's grouped inside the parentheses. On the bottom, what am I going to do first? Exponent. Okay, so then what do we end up with here? On the top, we've got our brackets containing a bunch of stuff. I've got a 15 minus in my parentheses. What am I doing with that first part? Yeah, so -6 plus 2, -4, right? Plus square root of 8 plus 1 is 9. On the bottom, we can take a step on the bottom also. On the bottom, we just get 3 minus, whoops, 27, okay? What's next on the top? Okay, okay, good, inside the parentheses. So what's that become? 4. What's that become? 3. Okay, so on the top, inside the parentheses, we're going to get 4 plus 3. Bottom was pretty simple. What do I get on the bottom? -24. And we're done with the bottom then, aren't we? Okay, up top. -15 minus 7. Oh, whoops, that's right. There's a squared there. Thank you. And on the bottom, we're done. I've got a -4 top. But before I can square, I've got to subtract inside the brackets. So I'm going to get 8 squared over -24. What's 8 squared? Okay, now that we got it down to a single fraction, first of all, let's deal with the coefficient. Positive divided by negative always gives us negative. I'm going to put that out front. So I've got the negative out front. 64 over 24. Can I reduce that fraction? What divides into both? 8 does. Good. So 8 goes into the top. 8 bottom. And we're done. Okay. Simplified fraction. Give me thumbs. We good on that? Okay. All right. I think that's good for today. Well, that'll get you through the next kind of warm-up assignment, the 1.3 practice 1. I'm going to call her quits. You guys can work, get questions answered.